Hi everyone, today we're going to look at a quick review of quartiles and how you use those to make box plots. This is what we did in our lesson yesterday, so fast forward, rewind, and do what you need to with this. Quartiles are really like medians. There's 4 quartiles. Second quartile is what we call the median, and this is the middle number. It's the 50% marker of your data. We call those percentiles. 50% of the data is below, 50% of the data is above. The median splits the data into 2 halves, upper half and a lower half, and the median of the lower half of your data set, and we order those low to high, so the smaller numbers, is called the first quartile. We give this one usually the subscript q sub 1. Up here for median, we don't really refer to it as q sub 2, but just fits into the pattern of the others. And then the median of your upper top half, the bigger numbers in your data set, is q sub 3, the third quartile. And I say the bigger numbers because sometimes when we have a set of data, low numbers are better, scores in golf, numbers of tardies, things like that. And you might think that's the better half of your data, but that's the lower half of your data if the numbers are smaller. And then the IQR, or the interquartile range, is our first measure of spread. Everything up to this point's been a measure of center, but this gives us an idea of how our data is spread out, and it's the distance between the third and first quartiles. We call this the middle 50% here, and this is a really important statistic. So this is our kind of our normal people in a data set, not our high values, not our low values, but just our middle values. And if we had a set of data, we wanted to find some of these values, first thing you would do, just like any set of data when you're trying to find the median, is you take that set of data. Here we have a bunch of stock prices from month to month to month, and we take that set of data and we would organize that from low to high. So your lowest value is 69, the next lowest value is 78, and so on up to 96. And what we have over here is called a 5-number summary for a set of data. And that is these 5 values right here, the quartiles, Q1, Q3, the median, and then our maximum and minimum value. When our data is in order, we can see all of these really, really easily. Our maximum value is clearly 96. Our minimum value is clearly 69. This value range is just your maximum value minus your minimum value. That's also a measure of spread. So in this case, 96 minus 69 is 27. Our medians are middle numbers, so if there are 12, 1, 2, 3, 4, 5, 6, and 7, this is our median value. If there's an even number of data values, your median is not going to be a member of the data set. So your median here is the average of 84 and 85, so 84 and a half. And then our lower half of data has 6 values. So again, we're not going to have a quartile that is a data value, but the middle of this set of data is going to be the average of 79 and 82. That would be the median of the lower half of data. So 82 plus 79 over 2. And that gives us 81 and a half. I'm sorry, 80 and a half. And then same thing for Q3, the median of our upper half of data. So there's 6 values, the average of the third and fourth in the upper half. So there's our Q3. So that would be 88 plus 91 over 2. And we get 89 and a half. From this, we can calculate our IQR, our middle 50%, our interquartile range. So that would be the distance between Q3 and Q1. So the IQR in this problem would be 89.5 minus 80.5, which is just 9. Once you get this 5-number summary, we can make a really nifty display. Box and whisker plot, we've seen this before. But this is a display that really does a nice job of showing how your data is spread out in a lot of different ways. You see each of the 5 numbers are marked here: minimum, first quartile, median, third quartile, and maximum. Those are all points on our box and whisker plot. But the middle 50% from quartile 1 to quartile 3 gets this box. And each of these little segments represent 25% of our data. Here's our middle 50%. Here's our upper 25% from Q3 to the maximum. And then from Q1 to the minimum is our lower 25%. And we start getting an idea of how our data is spread out. Our lower 25% is much more compact compared to the next 25%. Actually, the next two 25%. The upper 25% seems to be a little bit more spread out than the rest of the data. So, we might be asking what's going on up here when we see this display. We can also see the range off of this, which would be your max to your minimum. Making a box plot is really, really simple. If you have your 5-number summary, so based on a sample of 20 deliveries in this example from Big Bub's Pizza, it's determined that the maximum and minimum were 30 and 13, and then the quartiles, and then this is our median. Quartile 2 is 18. So the first thing you should do is make a scale that's accurate, because we want to see something out of this plot. The next thing I would do is put those numbers right on the scale, or on the number line of our 5-number summary. So there's 13, there's 15, 18. A little better scale would be a little more accurate, 22. And then our maximum value is 30. And then from there, we just start making our box. Well, that was a terrible box. With a line through our median, and then whiskers going out to Q1, or out to, our minimum, and our maximum from Q1 and Q3. And again, you can start seeing some patterns. On the low end, very compact. 25% of the deliveries are in this short low range. Up top, a little more spread out. Same 25%, same number of deliveries, 25% of 20 are going to be in this whisker over here.